Good morning, everybody, or good afternoon, or whatever time you're watching this. Today's lesson is for Friday, April 17th. I hope you guys are having a great week so far. Before I get to the notes, I did want to share a quick update. I'm recording this video on Tuesday, and tonight is the final countdown of our Munch Madness tournament with Jeanette. As just a quick update, the finals, we've got Apple, our #1 seed, against Purple Carrot Raspberry. So a bit of a dark horse. I'll keep you guys posted. Go ahead and jump to the notes. Just a quick lesson today again. All right, so here's some intro and admin. Speaking of final countdown, we're fast approaching that kind of end of semester time itself here. We've got 5 classes left, including today, and then the final exam. So just a couple reminders. Project 1, the new due date for that is Monday, April 20th. So please, try to put some finishing touches on that project, today and this weekend. Project 2, I am officially assigning it today, and it will be due on the due date of the final exam. So it's due on April 30th by 11:59 p.m. I think it shouldn't take hopefully too long for you guys to complete. So, you're welcome to submit it at any time before then as well. In terms of our remaining schedule, again, Monday we have Project 1 due. I'll do another one of these very short video lessons, just kind of reminding about some key due dates as we approach the end of the year. Wednesday, same deal. I'll post the practice final and just again, a short video. Please use that time to make progress on Project 2 with your partner. And then Friday, we'll do maybe a short review video for the final, just again, kind of big concepts, what to think about. Still waiting on some guidance about sort of what final exam week will look like, but if all things are sort of going as planned, I think the tentative plan on my side is to give an exam that's maybe a little bit shorter than the take-home exam for exam 2. It will be comprehensive with a focus on the most recent material, so this new environmental loading that we haven't really had an exam on yet. And again, the goal is to make it, not too long of an exam and maybe give you guys sort of like a day and a half to work on it and get it back to me. So that's the tentative plan, but again, subject to change given any guidance that comes down from the top. And then Monday we just sort of have course wrap up. So I think maybe we'll try to do some sort of, student opinion forums. I don't know if we'll do that like simultaneously or not, but I also will post probably a short PowerPoint video just kind of with some wrap up things for the class. And then also, depending on what you guys want, I'm really happy to do sort of a live question and answer about maybe the practice final. If another day works better, like maybe one of the reading days, please let me know, and we can kind of work out a convenient time. So please, send me a note or touch base with me in online office hours, and we can kind of make something work for that. And then again, Thursday, I'll give you as many details as I can about the final exams as they, become more clear. Last time, again, it was a short video, time to work on Project 1. Thank you to everybody. I've had a lot of great questions via email and on online office hours. So, keep up the great work. As a quick note, make sure that when you do your hand calculations, all you need to do here is do a statically determinate cantilever beam, summing the forces in the x direction, y direction, and then summing the moments about the base of your pile, so that connection between the ground and the bottom of the pile. You do not need to do the direct stiffness method to calculate Vmax, Mmax, and Pmax. If we had wanted to use the direct stiffness method, we could calculate deflections at the end of the beam, but for this problem, that's not a requirement. So just please don't hesitate to let me know if you have questions about that. Again, goals for today, just keep working on Project 1. I'll go ahead and just talk briefly through Project 2. I'll pull up the project assignment and an example and sort of consider it assigned today, but again, not due until the date of the final exam. So let me go ahead and share my screen. And here's Project 2. I'll post this in the same project folders under a new folder for Project 2. And I think this will be hopefully a really kind of fun way to think about how some of the simplifications we make in class are much more complicated when you think about real offshore structures, and also to investigate a little bit about, how offshore structures maybe are designed, how they're subject to different environmental loadings, etc. So again, you know, in this class, we've talked about how do we get the loads given environmental information like wave heights, wind speeds. How do we find displacements and reaction forces? So we can use either the direct stiffness method, or we can use something like STAT, a computational program, to do those matrices for us. And then how to assess the structure's suitability and safety based on things like design criteria. And we specifically focused on criteria from the American Petroleum Institute, but there are definitely other standards out there that are applicable to many other structures. For this project, I'd like you to choose a real world ocean or coastal engineering structure and kind of go through, you know, just a very basic process of thinking about how some of the concepts we talked about in class relate to this structure. And again, you can make a lot of simplifications. So for example, you know, here's just two ocean engineering structures, one from the United Kingdom and one from Florida. If I were to choose this coastal bridge, it would be totally fine to just say, I'm going to isolate kind of this pile system like we did for project one, and say, I'm going to really focus on the loads on one pile. And you can kind of assume that those are consistent along the entire length of the bridge. In terms of the deliverables, I'd like you to submit a 6-slide PowerPoint with some supplementary documents, you know, sort of some ported calculations that you can submit either as a JPEG of handwritten calculations or a PDF kind of, you know, typed up notes, whatever works best for you. But for the PowerPoint, you know, slide 1, just give me a picture and the name of the structure. Slide 2, do a little bit of research about the environmental conditions. Here you don't need to do anything major, like this isn't going to be a site analysis like you'll do for your capstone project next year, but I do want you to maybe have a look and see what information is out there about the location of your structure. So some great resources here are, you know, NOAA's website. NOAA has the National Data Buoy Center, which can give really good data on wave information, tides. Also, the U.S. Army Corps of Engineers provides some really good information about kind of return periods for different wave calculations. And again, you don't need to go through and pull like, you know, 20 years worth of data. If you just want to look at the last 5 days worth of data and then maybe add a safety factor that you think is reasonable. And again, as long as your assumptions are valid here and you clearly state why you're doing what you're doing, I'm very flexible with kind of these calculations for the design value. Because again, a lot of that comes down to engineering judgment. So, you know, just take some time to think about it, but you don't need to spend a ton of time, you know, pulling data, analyzing data, or, you know, looking for things like that. Slide 3, based on the environmental conditions that you decide in slide 2, I would just like you to do some calculations for a 5-foot pile diameter, assuming there's a water depth of 50 feet. And that it extends 15 feet above the still water level. So this is more of just a little bit of practice for the final exam, again, working with how we can calculate the wave and wind forces, assuming we know all of the environmental conditions. And then I think your spreadsheet for project 1 will be very helpful because, again, I'm asking you to calculate the total force at the time of the maximum wave force on the pile. So that sort of time of the force when the maximum wave force occurs. As a general note, a lot of times it's hard to find wave period information. So if you don't find that easily, go ahead and just assume that your period of the waves is 10 seconds. Slide 4 is our structural analysis slide. And here I'd like you just to talk me through the direct stiffness method and sort of, you know, with applications to STAT and applications to the direct stiffness method by hand. But, you know, is this structure a truss or a frame? And based on that, you know, how many stiffness matrices would you need? How big would these stiffness matrices be? Again, you can assume that it's 2 dimensions, so don't need to worry about bringing things into 3 dimensions here. And then how big would your system stiffness matrix be? And again, this is up to, again, you to sort of determine what you think a good simplified cross section of your structure is. So whether that's just one pile, whether that's a pile that's connected to, you know, a brace connected to another pile, so sort of like a 2-pile system, or even more, you know, maybe there's a truss system on an offer structure. Up to you, just show a sketch of me on the slide, what you're analyzing, and then how you're getting kind of the numbers for these questions. And then slide 5 is just any other interesting thing you think about the structure. So, you know, please have some fun with this. And also think about, you know, kind of how it's different from the structures that we've simplified in class. You know, basically the biggest difference is all of these structures have a lot more complicated things going on, complicated connections, real world uncertainties. But also there's kind of some cool things. So all the structures we've considered have been fixed to the seafloor or, you know, fixed somehow. So you might see that there's different ways of mooring offshore structures. There's new floating structures, something called a tension leg platform, which is pretty cool. And also feel free to, you know, go beyond. We've used steel, I think, for all of our monopiles, but a lot of ocean engineering structures are not built of steel. So go ahead and feel free to, you know, check out what the material type is and things like that. And then please, you know, just let me know where you found your information, just to cite your sources. I'd like you to try to find at least 3 sources. They can be online, all online sources. Obviously, we're kind of working on our computers these days. I listed some structure ideas. This is a very incomplete list. So go ahead and find something that is cool to you, interesting to you, maybe nearby your house or nearby, you know, where you are right now. And then just kind of assessment information.